So here we got a video on asymptotes. Now, before we talk about what is an asymptote, there are two types. There are those that are vertical and those that are horizontal. Now, an asymptote basically describes the behavior of a graph at its horizontal and vertical extremities. There seems to be some misconceptions about asymptotes. Some people might think, oh, it's a certain part of the graph you can't cross, or some sort of restriction or stuff like that. Really, the best way to think about it is how the graph behaves at its horizontal and vertical extremities. So, for example, say we had a graph that looked like this. And I drew an asymptote. So what this graph is telling me is that when we get very close, and let's say this is at 2, for example. When x gets very close to 2, from the right side, y is shooting up towards infinity. Or, another way to think about it, our y value will shoot up to infinity when it gets very close to 2 from the right side. So y approaches when x approaches 2 from the right. Over here, y will approach negative infinity when x approaches 2 from the left. So basically, all an asymptote is doing is describing how the graphs can behave at horizontal and vertical extremities. So, when we go to an extreme y value, whether it's high or low, we see that when we're getting close to 2 from the right or from the left side, y is either going up or down. Horizontal, so say we were to see a graph that looked like this. So with the dashed line here is a horizontal asymptote. So basically, when x is approaching infinity, and let's say this is at 2 again, y is approaching 2. So when we get very close to 2 for y, we see that x gets really, really large. So we're looking at basically the extreme values for x or y, and then what are what the other coordinate is approaching. So when y gets really big for the vertical asymptote, or really negative, it's approaching a certain value for x. Vice versa for horizontal, when it's getting very close, when x gets really large, we see that y gets very close to 2. So let's do some examples here. And you might want to use a graphing calculator to graph these. But for number 1 through 3, we're going to state the asymptotes. So we're going to state the vertical asymptotes for these problems. So for number 1, here we have f of x equals 1 over x. Number 2, f of x equals tangent x. And number 3, f of x equals log x. Now if you were to graph this in the calculator, you get something that kind of looks like this here. And if we think about it, when x gets really, really close to 0, y is either getting really big or really small. And plus you can't plug in 0. But what happens when you plug in values that are close to 0, you'll see this behavior for y, that either it's going to shoot up towards positive infinity or shoot down towards negative infinity. So clearly, x equals 0 is an asymptote for that first example. For number 2, if you graph this in the calculator, I believe you see something like this. And actually, it would repeat itself over and over again. So actually, there's going to be a whole bunch of asymptotes. But if I just state one of them, you'll find in the calculator this is going to be about 1.57. It's the same thing as saying pi over 2. And the reason why that's the case, if you were to plug in any x values that are very close to that, y would either shoot up or shoot down, depending on what side you're on. And then finally log x. Now these you did graph back in algebra 2. The graph would look like this, with your vertical asymptote like that, and number 1, vertical asymptote was like this. So again, we're going to have x equals 0. Reason being is that if you're plugging values very close to 0, like 0.1, 0.01, 0.001, you find that y gets close to negative infinity. So when x approaches 0 from the right, y is approaching negative infinity. Let's do a couple more examples so we can end the video here. For number 4 through 5, state the horizontal asymptotes. So number 4, let's look at 1 over x again. And for number 5, let's take a look at f of x equals 2 to the x power. Again, 1 over x we know looks like this if you graph in the calculator. 2 to the x looks like this. Now if I graph those asymptotes, now what happens here is that when x approaches infinity or negative infinity, y is basically getting very close to 0. If we make x really, really big, so we look at the horizontal extremities now, we see that y is getting close to 0. Or another way to think about when y gets close to 0, x approaches either infinity or negative infinity. So it's kind of reverse from a vertical asymptote. Same thing over here. When x is approaching negative infinity, we set y is approaching 0. So essentially, y equals 0 will be the horizontal asymptote for both of these. Now keep in mind, and we'll see different functions, a graph can cross its horizontal asymptote. It's at the extreme x values where that doesn't happen. And we'll talk about that on another video that deals with end behavior. But for now, we'll leave it at that for asymptotes. So this concludes the video on asymptotes.